Okay, this is the example. Okay, example number 2 in our lecture is based on your textbook. Okay, as you can see, there is some explanation regarding the figure. Okay, the figure shows an exothermic reaction controlled by cooling water. So this is your unit. Okay, let's have okay, this is your unit. Okay, we choose a reactor as a unit, and then you try your task is to find which one is your nodes and start doing your analysis or your studies. Okay, you have your feed, cooling water out, cooling coils, cooling water in, and also a thermocouple. This is the reaction control for your reactor. Okay, so the question is, consider the reactor system. Okay, the reaction is exothermic, so a cooling system is provided to remove the excess energy of reaction. Okay, in the event the cooling function is lost, the temperature of the reactor will increase. Okay, so it's basic information. Okay, when the cooling function is off, okay, your temperature inside your reactor will increase. This will lead to increase in reaction rate, leading to additional energy release. So this is the consequences from what happened when you lost your cooling function. You lost your cooling function, your temperature will increase. It will cause or the consequence is your reaction rate will increase, leading to additional energy release. So the result also could be a runaway reaction. Okay, you have your runaway reaction as your consequence. Okay, so the result will be runaway reaction with pressures exceeding the bursting pressure of reaction vessel. The temperature within the reactor is measured and is used to control the cooling water flow rate by a valve. So this statement is to explain what is meant by this exothermic reaction control. Okay, so the question is, perform a hazard study on this unit to improve the safety of the process. The design intention is cooling. So remember, inside your equipment, you could have your design intention, maybe a process intention. So for this one, just focus on cooling. Okay, just focus on cooling function. That's your intention for this task. Okay, maybe the other task could be the same reactor, but the design intention focus towards the process. Okay, process inside this reactor. So you will need a different heads-up studies for that one. Okay, so we focus on design intention is cooling. So we just target for cooling reaction control. Okay, so this is your example. You have your example 10.2 reactor of example. So reactor shown as example 10.2 in this section. All right. So remember, your intention is for cooling. So your study notes will focus more on cooling parts, cooling coils, and so on. So for study note of cooling coils, remember the previous slide. Okay, you have cooling coils. Okay, then later on you have your cooling water in, also cooling water out, and also there is thermocouple effect. Okay, so for cooling coils, you choose one process parameters first. Okay, choose flow. Okay, so flow, then you have a few deviation guidewords: no, high, low, and all of the combination. So try to combine this deviation word and also the process parameters. So no flow inside your cooling coils. What is the possible cause? No flow of cooling coil. No flow in cooling coils. So it may be caused by control valve fail close, and also the plug cooling coils can be caused or can affect these cooling coils. Okay, so the plug or the close of control valve will cause no flow of or no flow in cooling coils. So you will look, okay, what is the possible causes and the possible consequences. So the consequences is referred back to your possible causes. Okay. So when your control valve will close, what will happen? You will loss of cooling and also possible runaways. Okay. The same one goes to what will happen when your cooling coil is plugged. Okay. So the possible consequences is also loss of cooling and also possible runaway. So what action that you need, what action need to be taken so that we can prevent these hazards? Okay. So for the first one, control valve is closed. You need to install or select valve to fill open. So for the second part or the second causes, plug cooling coils, there are another action or another recommendation. Okay, install filter and so on. So number 3, cooling water service failure have the same possible consequences, but you need another or other action required. Okay, check the monitor reliability of water service. Okay, so possible causes will relate to possible consequences, and possible causes also will contribute to the action required. Okay, so after you finish all the listing of possible causes, consequences, and action required by the deviation of word no, we start a new one. Okay, item 1B2. Okay, 1B2 is using high. Okay, high. So high flow in cooling coils. What is the possible causes? What is the consequences? And also, what is the action required? Okay, so you see, then we start another one, 1C, because the same study note by low, and then as well as part or reverse. Okay, reverse as well as part of reverse and so on. As you can see, if the action required or the possible consequences already the same as previous, you can just use some notation. Okay, for example, loss of cooling, all of these referring to the same consequences. Okay, so if your action required or your recommendation already been recommended, okay, so you just cite back where is your recommendation. So see 1A 2, okay, 1A 4 and 1A 1 and so on. Okay, so 1A 1 is 1A 1. Okay, so the action required for the number 5 of possible causes is same as a possible action required by number 1. Select valve to fill open. Alright, so just try to reduce or make your table less complicated. Okay. Another point that you need to understand or you is worth to note is wait. Okay, you have action. Okay, yeah, regarding your experience. Okay, some people, okay, just like what I'm trying to explain previously, some people maybe just can find until 3 or 4 of the possible causes. Some people maybe find 5 to 6 possible causes. So it's all depend on your understanding or your experience and your knowledge regarding the hazards and also the equipment. So basically there is no right and wrong on what is in your hazard studies, just all these causes, consequences, and action required or your recommendation should make sense. Okay, should make sense to your analysis and studies. Okay, this is the potential process modification. It's only some modification after you have your recommendation. So you have a list of your recommendation to prevent the consequences and also the possible causes. So you can make the modification from this recommendation. Okay, so basically the same apply to example number 3. Okay, we will look what is example number 3 in next video.